Hi friends, welcome to the Unit 2 Day 1 notes. Now we're going to talk about some examples with circles. Here we're talking about the diameter of a circle has these endpoints. So these points are kind of on the edge, or the outside part of the circle. It says find the center of the circle. If I think about where the diameter is, so the diameter, those are going to be the points that are on the outside. If I want to find the center, then that means I need to find the point that's exactly in the middle or between them. So in this case, if I want to find the center and I have the diameter endpoints, what I can do is I can just find the midpoint of these two. So finding the midpoint will allow me to find the center. Those two would mean the same thing. If you need to make a visual representation to help you with that. So for here, if I find the midpoint of these, I'm going to take -3 plus 4 divided by 2, and -2 plus -3 divided by 2. Just the averages of your x's and the averages of your y's. -3 plus 4 is 1, so that's going to be 1/2. And then -2 plus -3 is -5. That's going to be -5/2. If it says leave it in improper fraction, you'd leave it as this, as a decimal, 0.5 and -2.5. So the center is at this ordered pair. Find the length of the diameter of the circle in number 3. So if I wanted to find the length of that, we're going to use the distance. So this is the distance formula. So d equals the square root of, so let's go ahead and take 4 minus -3. So 4 plus 3 plus -3 minus -2, so -3 plus 2 squared. All right, so that's going to give me 7 squared plus 1 squared. Made my square root way too far. D equals, that's going to be 49 plus 1, so that's 50. All right, so this is kind of what I talked about in the previous video. The square root of 50 we can reduce or simplify. We can take the square root of 25 out of that. And so that's going to give us the square root of 25 times 2, or 5 square root of 2. This is the diameter of this. Remember, this is the diameter. And what we want is we want the radius. So to get the radius when we have the diameter, this is going to be the diameter. So to get the radius, we just divide by 2. So radius divide diameter by 2. So that's going to be 5 square root of 2 over 2. That is okay to leave it in that form, and we don't have a radical in the denominator. It says now write the equation of the circle in standard form. So if I do that, what I'm going to have is, so I know my center is this, so I'm going to have x minus 1/2 squared plus y plus, because it's going to be -5/2. 5/2, oops, sorry. I already took care of that negative. Squared is equal to 5 square root of 2 over 2 quantity squared. Sometimes when you see this written out, they'll go ahead and square this right here. They'll square this value, and you'll end up with kind of a simplified answer. When we write it like this, what I want you to see is that it's and the difference of x's squared, the difference of y squared, and then the radius squared. On a test, if I asked you to give me the equation, I am actually looking for this squared out. So you would square this out completely. Make sure when you square it correctly. When we get done with this one, we have x minus 1/2 squared plus y plus 5/2 squared equals 25 times 2 is 50. 50 divided by 4. 4 54ths. That reduces, I think, just by 2, though. Yeah. So that's going to be 25/2. 25/2. Done with that one. Number 7, the following points are vertices of a triangle. Is it a right triangle? Then show your work to justify your answer. There's going to be a couple ways that we can do to figure this problem out. This graph only goes to 7. It doesn't go quite far enough. So -8, 1. So I'm just going to go 1, 2, 3, 4, down 1. So I'm actually going by 2's on this entire grid. -2, 9, -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, I'm going by 2's on the entire grid, and then 10, 0, 2, 4, 6, 8, 10. There we go. Okay, so now I want to know, are these vertices, is this a right triangle? Now there's two ways to approach this problem. Knowing that the slopes have to be opposite reciprocals, that's one way. If I look at this, I'm going to have this value here, this value here, this distance here, and this distance here. So there's two ways. Remember, for perpendicular lines, for it to have a right angle, this would have to be a perpendicular line. I'm assuming this one because this is the closest to looking like it's a right angle. The other ones don't. If I just get a piece of paper, since I graphed it, again, I graphed it with the same X and Y scale. You can only do this if you graph in the same X and Y scale. If you don't, it's going to be off. So for here, just kind of knowing that going forward, I could have kind of two ways. So one way is opposite reciprocal slopes. Because then that would mean they're perpendicular lines. Or what I can have is a confirmation of the Pythagorean theorem. A squared plus b squared equals c squared. That would mean I need to find the distance of all of these values. Opposite reciprocal slopes, I would just need to find the slope of this line and this line. All right, so moving forward, if I wanted to find a squared plus b squared equals c squared, I'm going to be taking the distance of these. So I'm going to take the distance from a to b. So the distance from a to b, the distance of a segment, so the distance of a to b, distance of a to b is equal to square root of, so here I have negative 2 plus 8 squared plus 9 minus 1 squared. So negative 2 plus 8 is 6. 6 squared is 36. 8 squared is 64. That's going to be 100. That's going to be 10 units. So this is 10 right there. The distance from B to C, square root of 10 plus 2, quantity squared, plus, there we go, 10 plus 2 quantity squared, and then 0 minus 9 quantity squared. Yeah, so that's going to give me, let's see, square root of 12 squared, so that's 144. 9 squared is 81. I think that's 255. No. No, that's not 255. 225. And the square root of 225 is 15. And then for the last one, oh, I put that in the wrong spot. From A to C, excuse me. So square root of, all right, so 10 minus 18, so 10 plus 18. Or sorry, 10 plus 8, whew, plus, and then 0 minus 1, quantity squared, that's 18. And then 18 squared plus 1 squared. 18 squared, I don't remember off the top of my head, I used to. 324. Plus 1, so 325. And then just quick verification that it's not a perfect square. It is not. I could probably take a perfect square out of some of this though. So if I do that, let's see. That's going to give me, let's see. I could take a 25 out, I believe. 325 divided by 25. Yep. So that's going to be 5 square root of 13. All right. So looking at this, to verify, it's actually easier to kind of go back a step where I didn't reduce all the way and I have everything under the radical, because I can check to make sure that this is in fact through the Pythagorean theorem, I can check to make sure that this does in fact work. In fact, if I look at this, I'm going to have square root of 100 squared plus square root of 225 squared is equal to the square root of 325 squared. Now remember, square roots and squareds cancel each other, so then you have 100 plus 225 is equal to 325. And that is true. 325 does in fact equal 325. So yes, this is a right triangle. Yes. This is a right triangle. And that's all my work to justify it. Join me in my next video as we continue through writing different parts of circles. Have a great day.